So our last section is compound events. So compound events are two or more events that happen. And so some vocab, we have independent events. So independent events do not affect how one another occur. So like flipping a coin and rolling a number cube, those things have nothing in common. So those are independent. Dependent would be when one event does affect another event. So if you have a bag of 8 marbles and you don't replace it, then you're affecting how many marbles are in the bag if you don't put that marble back in there. And then a mutually exclusive event is events that cannot happen at the same time. So for example, you can't roll 2 and a 5 on a number cube because there's only, when you roll, you only land on one side. And then overlapping events have outcomes in common, so kind of like a dog and a cat. So we're going to look at a few examples here. So determine first if these events are independent or dependent. So remember, independent, they don't affect each other, and dependent, they do. So choosing a number tile from 12 tiles and then spinning the spinner. Again, you have tiles and a spinner. So those things have nothing to do with each other. So that would be independent because you're not picking from a different bag of tiles or anything. It's just independent events because they have nothing to do with each other. They're two completely different things. And then you have down here, you pick one card from a deck of cards, and then without replacing the card, you pick another. And so this is going to be dependent, which I already have up here, but the reason it's dependent is because if you first pick one card, there's 52 total cards in a deck. So you have 52 possible cards to pick from. And then if you don't replace it, now you only have 51 cards. So you're affecting the probability because you're making it one less card to choose from by not replacing it. So the first pick depends, or the second pick depends on the first pick because that card will no longer be in the pile. So that's what makes it dependent. So now we look at our example. We're first going to do an independent probability problem. So here's your formula for independent probability. You're going to use the word and in the word problems, and then you're going to multiply the two probabilities together. So P of A and P of B just stand for the two different events that are going to be occurring. So if we look here at this first example, we have a desk drawer contains 5 red pens, 6 blue pens, 3 black pens, 24 silver paper clips, and 16 white paper clips. What's the probability that you pull a blue pen and a white paper clip? So that tells me that I'm going to use this formula, the P of A times P of B. So first I have to individually figure them out. I have to figure out P of A and P of B. So P of A, we're just going to pick. We could pick pens or paperclip. I just picked to do pens first. So remember, to get your probability, you have to do what you want over your total. So first we're going to figure out how many blue pens are there. There are 6 blue pens. And over my total, I've got 5 plus 6 plus 3 pens, which gives me 14 pens. So there's a 6 out of 14 chance that I choose a blue pen. And I'm going to simplify that to 3 over 7. So my fractions are already simplified. Now we're going to do the paper clip. So we want a white paper clip. So if I do my white paper clip, I have 16 white paper clips out of 16 plus 24. So my total paper clips is 40. So there's a 16 out of 40 chance that I choose a white paper clip. Again, divide the top and bottom by 8. So I'm going to get 2 out of 5 chance that I pick a white paper clip. And then to get my answer, I have to do my formula here. I have to do my P of A times P of B. So P of A is 3 over 7 times P of B is 2 over 5, which gives you 6 over 35. Chance that you choose a blue pen and a white paper clip when you reach in the desk drawer. Our next example is mutually exclusive events. So remember, mutually exclusive events are events that cannot occur at the same time. So our formula, you're going to have an or here in the middle instead of an and you're going to have a plus sign instead of a multiplication sign. So if we look here, in the high school, there can only be one sport played per season. So during the fall season, 20% of students play basketball and 24% play or are on the swim team. So what's the probability that the students selected play basketball or are on the swim team? So that or again tells us we're going to be using the addition one. So to get the probability of basketball or swimming, we have to add the probability of basketball to the probability of swimming. So our probability of basketball is 28%, and our probability of swimming is 24%. And if we add that together, we get 52% chance that they play either basketball or that they swim. And then our last one is overlapping events. Remember, overlapping events are things that have something in common. So your formula here is what you're going to do. Again, it's going to kind of look like or, but we had two different things in the last problem, but this one we're going to be using the same item. So last time we had basketball and swimming, those weren't the same. Here, if we look at the problem, we're using a number cube for both events. So that's why we have to, this is how we know to use the overlapping formula. So we first want to figure out the probability of rolling an even number. So if we have a cube, there are 6 different sides on the cube. And so our difference for even numbers, we've got a 2, a 4, and a 6. So I've got a 3 out of 6 chance that I can roll an even number. Then I have to figure out, it wants to know my multiples of 3. So if I think about a number cube, again, I got 1, 2, 3, 4, 5, and 6. Well, 3 is a multiple of 3, and so is 6. So I'm going to do, I've got 2 out of 6 chance that you have a multiple of 3. And then what we have to do is we have to figure out if there's any overlapping. That's why it's called an overlapping event. So overlapping means that it's even and it's a multiple of 3. So it includes both of these. So if we look here at the numbers I wrote out, I've got a 6, which is even, and 6 is also a multiple of 3. So there's a 1 out of 6 chance that I'm going to overlap. So we have to account for that, and that's why we have to subtract it from our total. So I'm going to do my P of even, so my 3, 6 plus the chances I get a multiple of 3, which is 2 out of 6. But then I have to subtract that overlapping one, which is the 6, because it occurs twice. So I can't count it twice. That's why I have to subtract it. And then you're just going to do your math. So when you're adding and subtracting, make sure you have the same denominator. So 6 stays on the bottom, and then 3 plus 2 is 5, minus 1 is 4. And then I'm going to simplify that down to 2 over 3. So there's a 2 over 3 chance that I roll an even number or a multiple of 3.